So we are going to cover the hemispheres of the brain in some major areas. This is the cerebrum. This little brown area here is the cerebellum. Our frontal lobe is going to be comprised of this area here. And we can see that on the inside portion. So the frontal lobe is responsible for personality, emotions, higher order thinking. As we move back here, we're going to have this deeper delineation. Okay, this is called your central sulcus. Okay, and so it's pointed to by number 5. And then in front of that, we're going to have our precentral gyrus, number 6. And then number 7 is going to be our postcentral gyrus. These are significant because this is where our motor cortex is housed. So this is how we initiate voluntary motor movements, things like that. So the motor cortex will also be housed within the frontal lobe. Okay. As we move past that central sulcus, we're going to move into our parietal lobe. So the parietal lobe is going to be responsible for sensory information. So is something hot? Is there pain? Am I balanced? Where is my body at in space? Proprioception. I know how my hips are going to be stacked over my knees, over my ankles when I decide to jump off this table onto the chair. Okay? Too bad we're not in class because I actually do that. Ask Maggie. I do climb on tables.
It's true.
As we move, we'll go ahead and go inferior. So this deep line here, this is going to be your lateral sulcus. The sulci are deep, so deep down. If you think about if you're sad about something or you're down, you sulk. Okay, these just help serve as dividing lines. So this lateral sulcus will help divide our parietal lobe and frontal lobe from our temporal lobe. Temporal lobe is going to be responsible for hearing, not only written language, but also spoken language, as well as music, writing, things like that, interpreting that. Okay. And then as we move to the posterior portion, we're going to have our occipital lobe here, number 3. Occipital is responsible for sight, so being able to interpret the images that we see and giving them significance. So the fact that I look at this and I know that it is a brain, and the fact that I know that this is also a brain, because I have a lack of examples. Okay. And then the cerebellum here, this is actually responsible for fine-tuning motor skills. It does not initiate any motor movement, but for being able to, for example, I played soccer up until my late 20s, all right? And so the fact that I haven't played in a couple years, I can still go out and kick a ball better than someone who's never played before. So it's enhancing those motor pathways that we've already come and, reinforced. It reinforces those pathways. So the ability of me to be able to pick this up fluidly and smoothly, not punch myself in the face with it, or write a paper, or drink out of a coffee cup, that's what the cerebellum is for. Okay? And so as you start to develop new habits, new hobbies, things like that, they will shift from this, the frontal lobe and the voluntary motor cortex to the cerebellum. Okay, so as you become more skilled at playing the piano or running or whatever, they will shift back here. So remember, it does not initiate any motor movement, it just fine-tunes it. Okay? As we go to the inside of the brain, we can see the inside of the cerebellum here, these tree-like, branch-like structures, that's called your arbor vitae. This area here, this 10, number 10, this is called your corpus callosum. This is responsible for connecting the different hemispheres of the brain and relaying signals from left to right. So the right side of the brain does control the left side of the body, and vice versa. However, there is no such thing as brain lateralization, meaning there's no such thing as being right-brained and or left-brained. Okay? Where they say, left brain is logic and right brain is creative. You use both sides of your brain for various things. Okay? Now, some psychologists will argue, however, there have been many physiological studies that show that it's not true. As we continue on, we're going to have our 22 about is going to be our thalamus. Okay? This is our integration center. So this is what's responsible for telling us what information is important and what information we don't really need to pay attention to. So for example, the fact that we're sitting here and we don't really notice the fact that our clothes are on our back or our shoes are on our feet, the thalamus is integrating that information out. Okay? Or if someone were to walk down the hallway with a cart, I wouldn't pay any attention to that because that's normal. Now, if I were out walking my dog and then all of a sudden a gunshot went off, that's something significant. The thalamus is going to send an alert, say, hey, pay attention to this. This is not normal. Okay? Whereas if a car drove by, I would ignore that. Okay? Because it's something in my normal routine that I'm used to that's not out of the ordinary. 21 would be our hypothalamus. Now the hypothalamus is considered the control center of the brain. It does all kinds of things from hormone release to thirst control, hunger control, temperature regulation. So this guy is super important when we talk about maintaining what's called homeostatic function. Okay? Let's see. Oh, also with the thalamus, I forgot to mention, the thalamus does not downregulate or dull pain. Okay? Because pain is what keeps you alive. So the thalamus lets all of that through, as much as that sucks. Then we get into the brainstem here. So this is going to be the pons. The pons plays a role in, it'll have a respiratory center, cardiovascular center. It can play a role in sleep. Okay? So it helps regulate your rhythmic breathing cycles, your rhythmic heart cycles. And then there has been some research that shows that it helps with some circadian rhythms. Medulla oblongata, this guy here, which will then drop down into the brainstem. This also will contain respiratory centers, cardiovascular centers that help or work with the pons to help create that rhythm to maintain those. We'll have our pineal gland that will sit kind of posterior back here. This is going to play a huge role in the release of melatonin. Okay, so melatonin is this hormone that has played a role in circadian rhythms. So the fact that we're diurnal, we're up during the day and we sleep at night. Melatonin does not cause you to go to sleep. So if you take melatonin as a supplement, you're wasting your money. I'm going to save you like $50 a month. So melatonin has been found to help make you sleepy and tell your body, hey, it's time to go to bed. But melatonin does not cause you to go from a conscious state to an unconscious state. Okay? However, the placebo effect has been shown to be very effective. So something to keep in mind.